Hello and welcome to this video tutorial. In this tutorial, we are going to talk about stoichiometry. I'm going to teach you some basic principles which you must know in dealing with calculations pertaining stoichiometry. Let's begin. Before we begin solving problems revolving stoichiometry, I'm going to tell you the fundamental things you need to know and consider on solving stoichiometry problems. The very first thing you do when you are solving this type of problem is to balance a chemical equation. The chemical equation will just be given in the problem. So let's say, for example, this is the chemical equation. Oxygen gas reacts with hydrogen gas to form a molecule of water. How do you balance the chemical equation? Well, you can balance the chemical equation by having the same atomic number of atoms of a single molecule on this side to this side. So as you can see, there are two oxygen atoms on this side and only one. So we can write a numerical coefficient of 2 to make it balance. So there are two oxygen atoms in each side. Now in this side, we have two hydrogen atoms and 4. 2 times 2 is 4. So we are going to write 2 here. Now that is a balanced chemical equation. The other thing you need to do is the type of problem you are going to face or tackle when you are solving stoichiometry. There are three types of problem you are going to face. First, a problem that will ask you to convert the mole of substance A to the mole of substance B. The second type of problem is you'll be given the moles of substance A and convert it to the grams of substance B, or the mole of substance B to the grams of substance A. That is the second type of problem. The third type of problem is you will be given the grams of substance A and you're going to convert it to the grams of substance B. So these are the three types of problem that you are going to face when you solve stoichiometry problems. But don't worry, we are going to discuss each of these in the video tutorial. Let's go to the first problem. Okay, so this is the first problem that we are going to tackle. Sulfur dioxide reacts with oxygen gas to form sulfur trioxide. If 3.4 moles of sulfur dioxide reacts with excess oxygen, how many sulfur trioxide are formed? Okay, so as I said, the very first step we're going to do is to write the chemical equation and then balance it. So sulfur dioxide reacts with oxygen gas and form sulfur trioxide. How do you balance the equation? Okay, so as you can see on both sides, the number of atoms of sulfur is already equal, and we have 4 oxygen atoms here. Then there's only 3 in this side. So let's start by putting 2 on each side. Now as you can see, the equation is already balanced. We have 2 sulfur atoms on both sides and 6 on both sides. That's 2 times 3 is equal 6. 2 times 2 is 4 plus another 2. So there's only 6. So it's already balanced. So now we have a balanced chemical equation. Now let's solve the problem. If 3.4 moles of sulfur dioxide reacts with excess oxygen gas, how many sulfur trioxide are formed? So we are tasked to calculate the number of moles of sulfur trioxide formed after the reaction of sulfur dioxide with excess oxygen. So we are tasked to calculate the number of moles in substance B by the given moles of substance A. So let's first write the number of moles of substance A, which is 3.4 moles of sulfur dioxide, and the number of sulfur dioxide reacts in the reaction to produce a mole of sulfur trioxide. So This is where the balanced chemical reaction takes place. As you can see, how many atoms of sulfur dioxide is needed to react in order to produce sulfur trioxide. So, there are 2 atoms of sulfur dioxide that reacts to produce 2 atoms of sulfur trioxide. So, 2 moles of sulfur trioxide needs 2 mole of sulfur dioxide to form. So, always put in mind that in doing this, make sure to put the labels to the place where you can cancel them. And now, let's do the math. 3.4 times 2 divided by 2 is 3.4. So this is the number of mole of sulfur trioxide that formed. Now is for the second number. Propane reacts with oxygen gas to form carbon dioxide and water. Okay, so let's write the equation. Propane, which is C3H8, reacts with oxygen gas to produce carbon dioxide and water molecule. Now, let's balance the chemical equation. Since there are 3 atoms of carbon in this side, and there's only 1, so in order to make it balance, we have to write a numerical coefficient of 3. So, there are 3 carbon atoms in this side, and also in this side. Now let's go for the hydrogen atom. There are 8 hydrogen atoms on this side, and there's only 2. So it makes sense that we have to divide in order to get the right numerical coefficient to be written. So 8 divided by 2 is 4. So as you can see, we have a balanced atom of hydrogen. 8 hydrogen and 8 hydrogen from 4 times 2. Now, we only have 2 oxygen atom in this side. And in this side, we have 3 times 2 is 6 plus 4 times 1 is 4. So 6 plus 4, we have 10 oxygen atoms in this side. And there's only 2. So we will just going to put 5 to have 10 number of atoms of oxygen in this side that is equal to this side. So now that we have a balanced chemical equation, we can pretty much solve the problem. Now, before solving, we must understand what is the problem is asking. If 2.8 moles of propane reacts with excess oxygen, how many grams of CO2 will form? So, it is asking for the grams of carbon dioxide. So, the blueprint of what we are going to do is to convert the moles of substance A to the moles of substance B and to the grams of substance B. That's what we are going to do. So there are 2 steps on solving this problem. Let's begin. So the mole of substance A is already given, and it is 2.8 moles of propane. And now for the second one is the reaction. We're going to put, since the question is asking for the grams of CO2, so you're going to find how many CO2 react as a mole of propane reacts. So as you can see in our chemical equation, for a mole of propane C3H8, there's 3 carbon dioxide that reacts. So 3 moles of CO2. So we can cancel this unit. And now, since we are on the mole of the substance B, we are now in the second step. We're going to convert this mole to the grams of carbon dioxide. How do we do that? Well, you need a periodic table to do this. First, we will write the chemical equation of carbon dioxide, which is CO2. That means there's 1 carbon atoms and 2 oxygen atoms. And to convert the mole to grams, you must first find the atomic mass for these atoms. Carbon atoms had a atomic mass of 12.01 and the oxygen has 16. You can find this in the periodic table. You'll know what I'm talking about. So, since there are 2 atoms of oxygen and CO2, so let's multiply 16 by 2 and that's 32. And 12.01 plus 32 is 44.01. And when you're adding the atomic mass, the answer is always in gram per mole. So, based on what we get, 1 mole of carbon dioxide has a grams of 44.01 grams of CO2. I can cancel that. So, since we cancelled pretty much everything except for this unit, that this will be the unit of our answer. Now let's do the math. 2.8 times 3 times 44.01. The answer is 369.7. So this is the answer. There are 369.7 grams of carbon dioxide that is formed when a 2.8 moles of propane reacts with the excess oxygen. So now we are in the third problem. Aluminum reacts with chlorine gas to form aluminum chloride. So with that statement, we are going to write the equation. Aluminum reacts with chlorine gas to form aluminum chloride. So you can pause this video and balance the chemical equation before I do. Just unpause it if you're done. So in order to balance it, since the aluminum atom is already balanced, let's proceed with the chlorine atom. There are 2 atoms in this side and 3 on this side. So in order to make it balanced, we have to find the least common factor of these 2. So let's put 2 here and 3 in this side. So 2 times 3, we have already 6 chlorine atoms, and on this side 3 times 2 chlorine atoms is also 6. But on this side, aluminum atom has become 2. So we're going to put 2 in this side. So aluminum atom has 2, aluminum atom has 2. And now we have a balanced chemical equation. So now that we have a balanced chemical equation, we can solve the problem. Okay, the problem asked, if 35 grams of aluminum reacts with excess chlorine, how many grams of aluminum chloride will form? So based on the problem, we are asked by the grams of substance B. So this time, we are given the grams of substance A. So another step will be added on how to solve this problem. So we are given the grams of substance A. We are going to convert it to the mole of substance A to the mole of substance B so that we can get the grams of substance B. It is necessary to convert it to mole before we can go to grams, so that we can cancel it during the process and there will be no problem in the units. So before I begin, you can freely pause the video and just resume if you're done, so that you can practice solving. Okay, let's begin. So there are 35 grams of aluminum as the reactant. And now, to convert the grams of the substance A to the mole of substance A, we're going to find how many grams of aluminum is in a single mole of aluminum. Recall what I said on the previous example. How do you find the grams of a substance? You're right. Look at the periodic table, and the atomic mass is the mass of a certain of and not the certain object, but the mass of a molecule. 1 mole of aluminum is 26.98 grams of aluminum. You can find it in the periodic table. Sorry for my ball pen. Now we can cancel this. Now we have the mole of substance A. As the step says, now we have the mole of substance A, we are going to convert it to the mole of substance B. Okay. How do we do it? You're right. We are now going to look at the chemical equation. So, how many mole of aluminum reacts to produce an aluminum chloride? So there are 2 aluminum atoms that reacts to produce 2 moles of aluminum chloride. So there is 2 aluminum chloride that is that formed when 2 aluminum, I forgot to put the mole, sorry. Never forget the unit. It's very important in solving. So there, in 2 moles of aluminum that reacts, it produces 2 moles of aluminum chloride. And now for the last part. Now we have the mole of substance B. We are going to convert it to the grams of substance B. So look again in the periodic table and look for the atomic mass of aluminum and chlorine. So aluminum has the atomic mass of 28.98 and chlorine has 35.45. But in aluminum chloride, we can see that there's 3 atoms of chlorine. So 35.45, you're going to multiply it by 3. So that is what we are going to put in this equation. So 1 mole of aluminum chloride has the mass of 133.33 grams of aluminum chloride. Cancel. If you are wondering how I get this, it's from this. Okay, now let's do the math. 35 divided by 26.98. We can just cancel this because 2 divided by 2 is 1. So 35 times 133.33 divided by 26.98, I mean, is equal to 172.96 grams of aluminum chloride. This is the unit you're going to use. So that's pretty much the answer. For the last part of this video, how many grams of hydrogen are in 46 grams of CH4O? You can just pause the video and do the problem first by yourself, then just unpause it to know how I did it. So in this type of problem, the problem is just asking of how many grams of hydrogen are present in this substance. So there is no reaction. There's no reaction. It is the problem just asks of the grams of hydrogen that is present in this substance. So there's no need to write a chemical equation. So, but as the previous example states, we are asked to find the grams of substance B from substance A. So let's start with 46 grams of CH4O times let's convert the grams to the mole of substance A. So to do that, we have to find the atomic mass of every atom found in this substance. So CH4O has 1 carbon atom, 4 hydrogen atom, and 1 oxygen atom. So the atomic mass of carbon atom is 12.01. Hydrogen atom has 1.008, and oxygen is 16. So since there are 4 atoms of hydrogen in this substance, you will multiply this by 4. So the answer on this is 4.032. So let's add them up. 12.01 plus 4.032 plus 16. The answer is 32.042. So in 1 mole of CH4O, there's 32.042 grams of CH4O. Now we have the value of mole for substance A. We're going to calculate for the mole of substance B. So in order to do that, on this reaction, how many hydrogen atom is found in this single substance? So in a single mole of CH4O, there are 4 hydrogen found. So there are 4 hydrogen molecule. The last step, since we have already the mole of substance B, we are going to convert it to the grams of substance B to get what is asked in the problem. So 1 mole of hydrogen has 1.008 grams of hydrogen. So cancel. Now let's do the math. 46 times 4 times 1.008 divided by 32.042. The answer is 5.78 grams of hydrogen are present in this substance. That is the answer.